Hello and welcome to the Unit 6 Section 2 video on special right triangles. So in the last section we talked about the Pythagorean theorem and how you can use it to find missing sides. We're going to shortcut that a little bit with two special cases of right triangles. So the first is a 45-45-90 right triangle, meaning that we have angle measures of 45 degrees, and 90 degrees in your triangle. A square has four congruent sides. Therefore, the diagonal of a square divides it into two congruent isosceles right triangles. Since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 45 degrees. So another name for an isosceles right triangle is a 45-45-90 triangle. It is one type of special right triangle. We'll get into a second type here shortly. You can use the Pythagorean theorem to find a relationship among the side lengths of a 45-45-90 degree triangle. So let's explore that. So here we have a squared plus b squared equals c squared, straight out of the last section of notes. Well, our sides are the same. You have x squared plus x squared, those are our legs, and our hypotenuse is going to be y squared. So this becomes 2x squared. This is y squared. If we take the square root of both sides, then we find that our relationship is x square root of 2 equals y. So what we find here is if we know what the leg length is of a 45-45-90 triangle, then we know that the hypotenuse is that leg times the square root of 2. This is the 45-45-90 triangle theorem. The hypotenuse is 2 square root of 2 times as long as the leg. So to find the missing sides in a 45-45-90 triangle, you set the length of the leg equal to L, or you set the length of the hypotenuse equal to L square root of 2. So let's try a couple of examples using this. I'll leave that up for the first two. So we are going to set x here. X is our hypotenuse, is what we're looking for. So x is going to be equal to L square root of 2. Well, our L is 7, so x therefore is 7 square root of 2. That's it. We have found the length of our hypotenuse. For b, we have our hypotenuse, we're trying to find x. So x is L. Okay? Our hypotenuse is 9 square root of 2. That is L square root of 2. Okay? That's our hypotenuse. Well, x is L, so 9 square root of 2 is equal to x square root of 2. And if we divide each side by the square root of 2, we find that x is 9. So our length of our leg here is 9. For example C, we know that our hypotenuse, x, is going to be L times the square root of 2. Well, our L here is going to be 10 square root of 2. And that gets multiplied by the square root of 2. Square root of 2 times the square root of 2 gives us 2. And 10 times 2 gives us 20. And then for D, we know that our hypotenuse is 3, so we're going to set 3 equal to L square root of 2. The length of our leg L is x, so that's going to be x square root of 2. And divide each side by the square root of 2, and you get your x. But we can't leave it this way. We have to rationalize it by multiplying the top and the bottom by the square root of 2, because we do not want any square roots in the denominator. So when we do that, we get 3 times the square root of 2 over 2. And that is our final answer. Do not leave square roots in the bottom of your fraction. A 30-60-90 degree triangle is another special right triangle. You can use an equilateral triangle to find a relationship between its sides and lengths. Recall, an equilateral triangle has 3 congruent sides with 3 congruent angles which all measure 60 degrees. Also recall that an altitude is a segment drawn from the vertex to the midpoint of the opposite side. Therefore, an altitude of an equilateral triangle divides it into 2 triangles with angle measures 30, 60, and 90. And you see that here in this figure. Okay, we drew our altitude and we divided our equilateral triangle into 2 congruent 30, 60, 90 triangles. So let's see what kind of relationship we can dig out of this. Let's start with our Pythagorean theorem. And let's look at one of our triangles, one on either side here. So let's start with A. Let's let A be x. Let's let B be y. So x squared plus y squared equals, and then finally our hypotenuse is 2x. So that gives us x squared plus y squared equals 4x squared. We can subtract x squared from each side and then take the square root of both sides. And when you take the square root of both sides, you end up with y equals square root of 3, or let's just put x square root of 3. So here we find that our long leg is going to be our short leg times the square root of 3. We also find that our hypotenuse is 2 times our short leg. So these are the relationships that you're going to use, and this is the theorem that we have proved here. In a 30, 60, 90 degree triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So to find the missing sides of a 30, 60, 90 triangle, you're going to set the length of the short leg equal to s, s standing for short leg, or set the length of the long leg equal to s times the square root of 3, or set the length of the hypotenuse equal to 2 times s. So let's do some examples here. Find the missing side lengths. And we are going to keep our answer in simplest radical form. So here we're given our short leg, 5. So we know that our long leg, x, is going to be our short leg, 5 times the square root of 3. And that is it. For our hypotenuse, we know that it is our short leg times 2. So it's 2 times our short leg, which is 5. So our hypotenuse is 10. For this one, we are given our hypotenuse. So we know that our hypotenuse is 2 times our short leg. So therefore, our short leg is 8. We can now use our short leg to find our long leg. Our long leg is our short leg, 8 times the square root of 3. For C, we have our hypotenuse again. So again, we are going to start with finding our short leg. So our short leg is, our hypotenuse is 2 times our short leg. And so our short leg is 9 square root of 3 when you divide each side by 2. Our long leg is going to be our short leg times the square root of 3. So 9 square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is 3. And 9 times 3 gives you 27. And then for D, we have our long leg. We know our long leg is our short leg, x, times the square root of 3. Divide each side by the square root of 3. And rationalize, and you get 11 square root of 3 over 3. And we know that our hypotenuse is going to be 2 times our short leg, which is 11 square root of 3 over 3. So we get our hypotenuse as 22 square root of 3 over 3. So that does it for these 2 special types of right triangles. The key to getting good at these types of problems is just to practice them. So that is what I encourage you to do at this point. The next section is going to be about similar right triangles, and remember, the next section is going to tie back to something we did in section 1. So that's coming up in the next video.